Let's just move on to the definition of what an exponent actually is, just in case you forgot. So an exponent is repeated multiplication of the same number by itself. It can be expressed as a power, and this number is said to be an exponential form. So here we have 4 to the power of 2. Now, in this case, 4 we would call the base, the number being multiplied by itself, and 2 is the exponent, what dictates how many times we actually do multiply it by itself. So it can be called the exponent, or some people also call it the power. So here we have 4 to the power of 2, meaning that we have to multiply 4 by itself 2 times, hence the 4 times 4. So now that you guys know that, let's delve into some questions. So here, express each expression as a number slash variable in exponential form and evaluate. So here, let's jump into question 1. We have 4 times 4. That's 4 being multiplied by itself 2 times, so 4 to the power of 2. And this would be 16. Now we have 5 times 5 times 5. This is 5 being multiplied by itself 3 times, so 5 to the power of 3, which is 125. Now, this one, a little bit more tricky, just because it has negatives in it, but still, it's fine. Negative 3 times negative 3 times negative 3. Right now, this is so boring. Negative 3, negative 3, negative 3 is equal to negative 3 to the power of 6. Now, if we calculate this, it would be 729. And you might wonder why this is positive, but we'll delve into that just in a second. So here, final question, 4r times r times r. And this is r being multiplied by itself 3 times, so r to the power of 3. Now, we do the opposite. Express each expression in expanded form and evaluate. So now, 2 to the power of 7 means 2 being multiplied by itself 7 times. So we write 2 times 2 times 2, 3 times 2, 4 times 2, 5 times 2, 6 times 2, 7. Now let's evaluate. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2, 128. Now for the second question, it's negative 3 in brackets to the power of 3, meaning negative 3 times negative 3 times negative 3. Now here we have negative 27. Here we have negative 4 non-brackets to the power of 3, meaning we leave the negative on the outside, and we do 4 times 4 times 4, which would give you negative outside the brackets, 64, and then we could just multiply the negative onto the 64. Finally, we have a fraction, which you might find tricky, but don't fear. It's the same process. It's 3/9 to the power of 2, meaning 3/9 multiplied by itself 2 times. So 3/9 times 3/9. Top times top, bottom times bottom. So 9/81, which is just 1/9 reduced. Now, here's the pattern I was talking about, guys. So, if you do negative 3 in the base, or just any negative, as a matter of fact, there's a pattern that you guys can see here. So let's just do it. And it depends on the power that the number is held to, if it's either even or if it's odd. So let's see if you guys can find it. Here, let's just evaluate each one beforehand. So negative 3 multiplied by itself 2 times, just 9. Same thing here, just 3 times this time. But this time we get a negative number. Now here, we have a positive number. And here, we have a negative number. So if you guys see something between the power of the number, whether it's even or odd, you can see that if the base of the power is negative and the power or exponent is an even number, the answer will be positive. On the other hand, if the exponent is an odd number, the answer will be negative. So that's just a pattern so you guys know. So if the base of the power is negative and the exponent is an even number, you will always get an answer that will be positive. And if the exponent is an odd number while the base is negative, the answer will always be negative. This is just a pattern. And it makes sense because if we have two negatives multiplied, we get a positive. So no matter how, but if we have 3, we will always get a negative. So this just adds the amount of negatives, but the pattern stays the same.